Okay, LINQ Extension Methods. Let's start with restriction. So back in Visual Studio, imagine we want to get all courses in level 1. So we start with context.courses.where. Now look, this method takes a func of course and bool. This is a delegate. If you're not familiar with delegates, it's best to watch my C# Advanced course. But a quick tip here is whenever you see a func, you can use a lambda expression. So here we can write C goes to, so C is short for course, and our condition, C.level equals 1. And we store the result in courses. Next, ordering. So back here, we can chain another method call, like order by. And again, we use a lambda expression. So C goes to, let's order them by name. If you want to order by multiple properties, you use then by, and let's say we order them by level. If you want to order in the descending way, you can use order by descending. And we also have a similar method for then by. So then by descending. Now, as you write more complex queries using LINQ extension methods, it's good to break them down into multiple levels so you don't have to scroll to the right and left. It makes coding a little bit difficult. So, where, like this. Next, projection. So, back here, we can call the select method and project these course objects into a different type. We could have a separate type, which is like a shorter version of a course, or we could use an anonymous object. Again, we use a lambda expression. So let's create a new anonymous object with two properties. Course name equals c.name and author name equals c.author.name. So know that because we have a navigation property here, author, we don't need a join, like how we do in SQL queries. We also have another select or projection method, which is called select many, and we use that to flatten a hierarchical list. Let me change this example. So instead of projecting into an anonymous object, I'm going to select tags for a course. Now let's take a look at the return type of this method. It returns an iQueryable of T, where T is an iCollection of tag. We'll get to iQueryable shortly, but for now remember iQueryable interface derives from iEnumerable. So it's like a list. So essentially what we're getting here is a list of tags. So imagine a list where each element is another list of tags. So if you want to use this, let's say we want to display all these tags, we'll end up with a nested for each block. So the first one would be like this. For each var C in courses, at this point, C gives us one element at a time in the courses object. But this element itself is a list. So we need to iterate over it again. So for each var tag in C, now we can display that tag on the console. Tag.name. Let's run the application. There you go. So the lesson is, when you're using the select method, if the target property is a list, you would end up with a list of lists. It's a hierarchical object. If you want to flatten it, you can use select many. This way, we'll end up with a flat list of tags. So I'm going to rename this variable to tags because we are returning tags. We're selecting tags, right? So courses is not a good name. And I'm going to change this. For each T in tags, display T.name. Let's run the application. There you go. Next, Set operations. Look, C# tag is repeated 3 times. To make it unique, we can use the distinct method. So, at the end, after we're done select many, we can call distinct. As simple as that. Let's run the application. There you go. Next, grouping. So as I told you in the last lecture, grouping in LINQ is different from grouping in SQL. In LINQ, we use group by to break down a list into multiple groups. So imagine we want to break down all courses by their level. So we want to get 3 groups, group 1, group 2, group 3, and each group will have all the courses in that level. So context.courses.groupby. Now look at the argument. Func of course and T key. So again, this is a delegate, which means we're going to use a lambda expression here that takes a course. And key is actually the property on which we want to break down this list of courses. So C goes to break it down by level. Now I can store the results in a variable like groups. Maybe it's better to put it on one line because it's too short. Now let's iterate over groups. So as I told you in the last lecture, each group has a property called key, which is set to this property here. So we display the group key or the level of courses in that group. And then we do another for each. So for each course in group, write line course.name. And I would put a tab just before that. So \t is the tab. Let's run the application. There you go. So level 1 and courses in level 1 and so on. Next, joining. So as I told you in the last lecture, we have 3 types of joins in LINQ. Inner join, group join, and cross join. Inner join and cross join are similar to how they work in SQL, but group join does not have an equivalent in SQL. So let's go through them one by one. We start with inner join. We use inner join when there is no relationship between our objects and we want to relate them. In this case, it doesn't make sense to use an inner join between courses and authors because the course class has a property called author. But imagine we didn't have this relationship. So we can use a join to relate courses and their authors. So back here, context.courses, join. Now look at the arguments of this method. The first one is an IEnumerable. And this is the list that we want to join courses with. So what is that list? It's the list of authors. So context.authors. Next argument. Here we have an expression of func of course and T key. When I first saw this, I freaked out. I had no idea what this meant. But it's actually pretty easy. Whenever you see an expression, you can kind of get rid of it. Just imagine that expression does not exist. So start from func. What is func? Func is a delegate. And whenever you see a func, you can use a lambda expression. So the argument to this func is a course, and the output is a key. So what property of the course class do we want to use in order to join it with authors? We want to use author ID. So we want to use author ID in the course and link it with ID in the author. So it's pretty easy. So here, a lambda expression, C goes to C dot author ID. Next argument. Look here. Again, expression of func of author and int. So get rid of the expression, you see func of author and int. With func, we use a lambda expression. So we're going to pass an author and return an integer. And that's the key in the author that we're going to use for joining. So A goes to A.id. So we are using the author ID on the course and ID on the author to join these two lists together. Now, question is, what should happen after joining? That's the purpose of the next argument. So look, expression of func of course, author, and t result. So we get rid of expression. With func, we use a lambda expression. This lambda expression takes two arguments, a course and an author, and that's when we're going to join them. And we're going to return a new object. That would be the result of joining. So, course and author in parentheses goes to, I'm going to create an anonymous object and join them. Let me get rid of this thing here. So look, new anonymous object. There you go. I'm going to give it two properties. Course name equals course.name. So the course object that we pass to this method will be used to set the value of this property. Next, author name. Author.name. And semicolon. That's it. Now to make this code a little bit more readable, I would personally like to break it down like this. So each argument on a different line. Like this. So we are joining courses with authors. Here are our keys, and this is the result of joining. As simple as that. Next, group join. So as I told you in the last lecture, group join is useful in situations where in SQL we do a left join between two tables and then use count, aggregate function, and group by. So let's say we want to get all authors and count their courses. So back here, we want to join authors with their courses. So context.authors.groupJoin. Look at the first argument, an IEnumerable. That's the target list that we want to do a group join to. So we want to join it with courses. Next argument, expression of func of author and key. Get rid of expression, func of author and key. So that's a key in the author entity. A goes to a.id. So I'm going to use the ID in the author entity and join it with the next argument. So expression of func of course and int. So we use a lambda expression for the course. C goes to, in the course we have author ID. This is exactly like the example we had in the join method. Next, what should happen once these records are matched? So with group join, as I told you in the last lecture, we have a list on the left and one on the right. Group join matches each object in the list from the left side with one or more objects with the list on the right side. So back here, in the next argument, we're going to specify what should happen once these objects on the left are matched with objects on the right. So look, the argument is of type expression of func of author and IEnumerable of course and t result. Wow, what a long name. We're going to simplify it. Get rid of expression. We have function. So here we're going to use a lambda expression. That lambda expression takes two arguments, an author and an IEnumerable of course. So it's like one author and the list of his courses. And then we're going to return something in that lambda expression. So author and courses goes to, I'm going to create an anonymous object. We can say author name equals author.name and courses equals courses. So this is going to return a number of objects. Each object is going to have a property called author name, which is a string, and a list of courses. Or we could just store the entire author object here, like this. Or here we could use count to just return the count of courses for each author. Next, cross join. So this is similar to SQL. We have a list on the left and one on the right, and we want to return every combination of every object in these two lists. So with extension methods, we don't actually have a method called cross-join. It's select many. So imagine we want to get list of authors and courses and combine them. So context.authors.select many. A goes to, but here's the tricky part. I'm not going to select a property from this author. Instead, I'm going to return context.courses. So this way, we're going to get all courses in the database. Now next, look at this argument. Expression of func of author, course, and tier result. So this is the result of matching. So we're going to create a Lambda expression that takes an author and course, that's one combination, and returns something here. So author and course goes to new. We can have author name equals author.name, and course name equals course.name. So that's a cross join.